For a moment, imagine staring out at the infinite expanse of space, where stars are not just points of light, but markers of possibility, each one a sun in a distant system waiting for us to discover it. Now, imagine trying to cross that vast, cosmic ocean at a speed faster than the very force that binds the universe together, the speed of light. For decades, physicists told us it was impossible. Nothing could exceed light speed. Spacecraft, messages, even thoughts themselves, constrained by the cosmic speed limit. Yet, today, that boundary, once absolute and unquestionable, is being challenged by new theories emerging from the cutting edge of physics, and scientists are beginning to suggest that faster-than-light travel might not be just a dream, but a blueprint within our grasp. In the next few minutes, we're going to explore what could be humanity's most ambitious leap into the unknown. A journey that could redefine not only space travel but our understanding of reality itself. The concept of a warp drive might sound like the stuff of science fiction, a fantasy conjured for movies and novels, but the truth is far stranger and far more precise. In 1994, a physicist named Miguel Alcubierre proposed a theoretical model, a way to bend spacetime itself so a spacecraft could ride a wave of distorted space, shrinking the distance between 2 points without ever technically breaking the cosmic speed limit. This warp bubble, as he described, would compress space ahead of the ship while expanding it behind, creating a moving corridor that effectively allows the ship to reach its destination faster than light itself could travel through normal space. At the time, the model was considered purely theoretical, largely because it required an impossible amount of negative energy, something that could warp spacetime but which, as far as anyone knew, could not exist in sufficient quantities. It was beautiful mathematics, elegant and tantalizing, but unachievable with the technology and knowledge of the era. Yet, despite its seeming impossibility, it planted a seed of possibility in the minds of those willing to look beyond conventional physics. And over the decades, that seed has grown into a serious field of study, pushing boundaries in ways that could change everything. Now, fast forward to 2025. Recent research suggests that Alcubierre's concept might not be purely theoretical after all. Scientists have discovered models indicating that warp bubbles could be formed without relying on exotic negative energy, instead using configurations of energy and matter that are theoretically possible within known physics. This revelation doesn't mean warp drives are ready to launch, or that humanity is on the brink of interstellar voyages tomorrow, but it does mean that the laws of the universe may allow for such travel, if only we learn how to manipulate spacetime with precision and control. The implications are staggering. It's no longer science fiction. It's a question of engineering, of scale, of imagination, and of our willingness to confront a reality far stranger than we've been taught to believe. But before we get lost in the mathematics, imagine what faster-than-light travel would truly entail. A journey to the nearest star system, Proxima Centauri, which normally takes decades even with the fastest theoretical spacecraft, could be reduced to mere weeks or even days. Interstellar exploration would no longer be a dream reserved for generations to come. It could become an achievable mission for the first explorers brave enough to command a warp-enabled vessel. The distances of the universe, once intimidating and unreachable, shrink under the promise of space-time manipulation. Galaxies that seemed impossibly distant become reachable, and with them, the mysteries of alien worlds, uncharted planets, and perhaps even evidence of civilizations far older and more advanced than our own. The excitement is undeniable, but so too is the danger, for bending spacetime is not a simple task. Even the slightest miscalculation could have catastrophic consequences, distorting reality in ways we cannot yet fully predict. This new approach to faster-than-light travel raises more questions than it answers, and that is part of its allure. How do we create a warp bubble with available energy sources? What materials or fields are necessary to stabilize it? Could this technology one day allow us to traverse not only space but time itself? These are not idle speculations. They are questions being seriously discussed in academic papers, laboratories, and conferences today. And as we examine these possibilities, we begin to realize that the universe is far more flexible, far more strange, and far more beautiful than we ever imagined. The warp drive is not merely a vessel for travel. It is a mirror reflecting our deepest curiosity, our relentless pursuit of knowledge, and our willingness to challenge the boundaries of reality itself. And here's the part that will make your mind reel. The mathematics underlying the warp drive suggests that spacetime can be shaped with precision, compressed and expanded in such a way that distances and travel times can be radically altered, all without violating the cosmic speed limit. The universe itself may allow shortcuts, corridors through spacetime, waiting for humanity to figure out how to navigate them. Imagine stepping aboard a craft, activating a warp field, and watching the stars stretch and blur as you traverse the cosmos faster than the speed of light. This isn't a dream. It's a future rooted in equations, experimental physics, and human ingenuity. Every theoretical calculation, every simulation, every experiment brings us closer to a reality where the impossible becomes possible. And so, as we begin this journey together, ask yourself, what would it mean if faster-than-light travel were no longer a fantasy? If warp drives become reality, the universe itself becomes our playground, and the limitations we once accepted may simply dissolve into the fabric of spacetime. In the next part of this video, we'll dive deeper into the physics, the latest breakthroughs, and the extraordinary theories that suggest humanity could, one day, bend the cosmos to its will. Prepare to have your perception of reality stretched, twisted, and expanded, because the universe might be far stranger than anything we've dared to imagine. Imagine for a moment that the speed of light is not an unbreakable barrier but a river, a current flowing through the universe. Traditional spacecraft are like swimmers struggling against that current, limited by the laws of physics and the immense distances between stars. But now, imagine bending the river itself, creating a flowing corridor that carries you faster than the water moves, without swimming harder, without breaking the rules of the river. This is essentially what the new warp drive model proposes. A way to shape spacetime, compressing it in front of a spacecraft and expanding it behind, forming a bubble that moves through the universe as if the cosmos itself were guiding it. Unlike older models, this approach does not rely on exotic, negative energy, which was long thought to be impossible to harness. Instead, it leverages configurations of energy and matter that could, in theory, exist within our current understanding of physics. It is a subtle shift, but one that transforms the warp drive from a mathematical curiosity into a potential reality. To truly grasp this, we need to explore the mechanics.
Imagine a bubble surrounding a spacecraft.
Inside, space remains calm. The ship and its passengers do not experience extreme acceleration or gravitational stress. Outside the bubble, spacetime is stretched and compressed, creating a corridor that reduces the effective distance between 2 points. This means that, relative to the outside universe, the spacecraft can travel faster than light. Yet from inside the bubble, everything feels normal. The brilliance of this idea is that it does not break relativity. It works within its rules. The universe allows space itself to move, and it is space, not the ship, that travels faster than light. The concept is both elegant and counterintuitive, challenging everything we think we know about motion, distance, and speed. Now, let's look at the practical challenges. The warp bubble is a fragile structure. It must be perfectly stabilized. The energy distribution must be precise. Any fluctuations could collapse the bubble or create dangerous distortions in spacetime. The calculations suggest that energy requirements, while still immense, are far lower than previous warp drive models. Instead of needing energy equivalent to the mass of entire planets, it might be reduced to a scale that, in theory, humanity could achieve in the distant future. It is still beyond our current technology, but it is no longer dismissed as impossible. And that small step toward plausibility is enough to excite physicists and futurists alike. It shifts the conversation from fantasy to feasibility, from science fiction to potential science reality. The mathematics behind this new warp drive are complex, but the principles can be understood with a few key ideas. First, spacetime is not rigid. It is malleable. Einstein's general relativity teaches us that mass and energy can bend spacetime, creating gravity. The warp drive takes this concept and applies it dynamically. Instead of bending spacetime around massive objects, it manipulates space itself around a moving bubble. Second, the energy required to manipulate spacetime is immense, but clever theoretical configurations involving quantum fields and precise energy gradients could reduce the burden to levels we might one day harness. Finally, the bubble can be shaped asymmetrically to optimize movement and minimize destructive effects, ensuring that the craft inside remains safe while space stretches and contracts around it. The theory is not just numbers on a page. It is a framework for understanding how our universe might be navigated in ways that were once considered unimaginable. The implications of such a technology are staggering. Faster-than-light travel would open the doors to interstellar exploration on human timescales. Colonies on exoplanets, exploration of distant star systems, even intergalactic travel, all suddenly move from distant dreams to potential realities. Consider the nearest star system, Proxima Centauri, 4.24 light-years away. At current speeds, it would take decades to reach. With a warp bubble, the journey could take weeks or months. Distances that once seemed absolute shrink under the flexibility of spacetime itself. And yet, even as we imagine this, the risks are profound. Miscalculations could tear spacetime, create intense gravitational waves, or even distort causality itself. Scientists are aware of these dangers, which is why the study of warp drives remains mostly theoretical for now. Another fascinating aspect is the potential effect on time. While relativity prevents traveling faster than light locally, the warp drive moves spacetime itself, which may create strange temporal effects. Passengers might experience time differently than observers outside the bubble. Could we effectively skip years of travel without aging, similar to the time dilation of near-light speed travel, but amplified? These are the questions researchers are beginning to ask, and each answer leads to more intriguing possibilities. If the theory proves viable, it might not only change our concept of space, but also challenge our understanding of time, causality, and the very structure of the universe. It is important to remember, however, that this is not a guarantee that warp drives will exist tomorrow. The energy, precision, and engineering challenges are astronomical. Building a warp-capable vessel would likely require advances in quantum field control, energy generation far beyond current limits, and perhaps even material science that we cannot yet imagine. Yet, the mere fact that the laws of physics do not explicitly forbid it is revolutionary. It transforms faster-than-light travel from a story told in fiction to a scientific frontier that can be explored, debated, and potentially realized. Finally, consider the philosophical implications. If humanity could one day travel faster than light, the universe itself becomes less intimidating, less distant, and far more interconnected. The stars are no longer unreachable points of light. They are destinations, waiting to be touched. We are not limited by the cosmic speed limit. We are limited only by our imagination, our courage, and our ability to manipulate the universe at a scale we have only begun to comprehend. And perhaps, in the not-so-distant future, a child looking up at the night sky could one day step aboard a warp-driven ship and travel farther and faster than anyone ever thought possible. The idea that our universe, so vast and so unyielding, could be navigated at will, is the ultimate testament to human curiosity and ingenuity. As we continue, we will explore the latest experiments, simulations, and theoretical breakthroughs that bring us closer to this reality, the potential technologies that could stabilize a warp bubble, and the incredible implications for humanity's future among the stars. Prepare yourself for a journey where science meets imagination, where physics challenges our perception of the universe, and where the impossible begins to look attainable. Now that we understand the mechanics of the warp drive, it's time to step back and imagine the universe through a new lens. One where the vast distances separating stars, planets, and galaxies are no longer absolute barriers. Faster-than-light travel would transform everything we know about exploration, civilization, and even our place in the cosmos. Imagine a spacecraft leaving Earth today, enveloped in a perfectly stabilized warp bubble, accelerating effortlessly while space itself folds around it. In a matter of weeks, it could arrive at a distant star system that previously would have required decades or centuries of travel. Planets that were once unreachable would suddenly be within human grasp, opening possibilities for colonization, scientific discovery, and encounters with environments that challenge our understanding of life itself. The very notion of the universe being infinite and unreachable begins to shift. It becomes navigable, tangible, and full of potential. Consider the implications for astronomy. A warp-capable probe could explore exoplanets, black holes, and nebulae with unprecedented speed. Data that currently takes years to collect could be gathered in months or weeks. Observatories could be positioned directly within distant star systems, observing phenomena in real time rather than through the distorted lens of light years of distance. And as this technology develops, humanity might no longer be limited to passive observation. We could actively participate in the evolution of the cosmos. We could move among stars, study alien worlds, and perhaps even encounter life forms far older or more advanced than ourselves. The universe that once seemed indifferent and inaccessible suddenly feels like a stage for human ingenuity and exploration. Yet, even as the dream of warp travel captures our imagination, there are ethical and philosophical questions we cannot ignore. What responsibilities come with the power to traverse the universe at speeds that defy conventional understanding? Could misuse of this technology create catastrophic consequences, tearing spacetime or disturbing the natural order of celestial mechanics? How do we ensure that exploration does not become exploitation, and that the fragile cosmic balance is respected? These are not trivial questions. They are the kinds of challenges that have accompanied every major leap in human history, from fire to electricity, from flight to nuclear energy. Faster-than-light travel would represent the most profound leap yet, demanding wisdom, restraint, and foresight alongside technical brilliance. The potential military and political implications also cannot be ignored. A civilization capable of warp travel could theoretically reach strategic locations anywhere in the galaxy faster than light. The question of who controls such technology and how it is used becomes critical. But beyond strategy and power, the sheer human drive to explore, to reach beyond the horizon, is what makes the warp drive most compelling. It taps into the oldest part of our nature, the desire to venture into the unknown, to uncover secrets that lie just beyond our reach, to stand on the edge of discovery and see what lies on the other side. Let's return for a moment to the science itself. While the energy requirements and precision needed are staggering, ongoing research into quantum fields, exotic energy distributions, and space-time manipulation is gradually turning theory into plausible experimentation. Some simulations suggest that smaller-scale warp effects could be tested in controlled environments long before a full-scale interstellar warp ship exists. Imagine testing a warp field around a probe within a lab or orbiting Earth, creating tiny bubbles of space-time distortion. These miniature tests could pave the way for larger, interstellar applications over the next decades or centuries. The process will be gradual, iterative, and painstaking, but the fact that it is even conceivable marks a paradigm shift in physics, engineering, and our understanding of reality. Now, consider the philosophical and existential implications. Faster-than-light travel challenges the very concept of distance, time, and isolation. It suggests that the universe is not an impassable void, but a connected tapestry, waiting for intelligent life to navigate its threads. It hints that humanity's potential is far greater than we have imagined, and that our destiny may not be confined to a single planet, a single solar system, or even a single galaxy. If the warp drive becomes reality, it will redefine what it means to be human, to explore, to innovate, and to grasp the universe in ways previously relegated to dreams. It is an idea that excites the imagination, ignites ambition, and expands the boundaries of possibility. And here's a moment to pause and reflect. The warp drive is not just a vehicle or a technology. It is a symbol of curiosity, of courage, of the relentless human desire to reach farther than we ever thought possible. Every calculation, every simulation, every experiment represents a step towards something extraordinary, a future where the stars are not distant points of light, but destinations waiting to be explored. The warp drive challenges us to rethink what is possible, to embrace uncertainty, and to envision a universe in which humanity is no longer bound by the limits of light, but guided by the possibilities of imagination and science. As we conclude this journey into the science, theory, and implications of faster-than-light travel, remember that this is just the beginning. The universe is vast, mysterious, and far stranger than we can comprehend. And while warp drives remain theoretical, each breakthrough, each new discovery, brings us closer to a reality where humans could truly traverse the stars. The dream is no longer confined to fiction. It is a challenge, a frontier, a call to explore. If you've been fascinated by this journey through science and imagination, Don't forget to subscribe to Lurix for more videos that explore the edges of reality, the mysteries of physics, and the frontiers of human knowledge. Comment below and tell us, if you had the chance to step aboard a warp-driven spacecraft, where in the universe would you go first? Your thoughts might inspire the next great exploration. And finally, as you look up at the night sky tonight, remember this: the universe is waiting. Its vast distances, its strange phenomena, its hidden secrets, they are not beyond us. They are a challenge. They are a story waiting to be told. And perhaps, someday soon, faster-than-light travel will allow us to step directly into that story, to journey across the cosmos, and to see the universe not as an unreachable void, but as a landscape of infinite possibility.